Welcome to Advanced Problems video. In this video, we are going to solve a high level and advanced level of problems. I hope you enjoy solving those problems. Then let's get started. Here is the first problem. There are a right triangle and an inscribed circle. The radius of the circle is 2 and the sides of the triangle are given as A, B, and 13 as you can see in the picture. Our goal is to find out A times B. The second problem asks us to find out the remainder R of x. It's the remainder that x to the 5 plus x to the 3 minus 1 divided by x minus 1 square. The third problem is about greatest common divisor and least common multiple. Our goal is to find out the second order polynomials m and n. And there is also the problem 4 that requires you to find out the value x and y. I will give you the solutions very soon, but I recommend you to try to solve those problems for yourself first. That will make watching this video more interesting and helpful. In 7 seconds, the solution part will appear. Okay, let's start with the first problem. This problem is not actually difficult if you know the character of inscribed circle. The problem says that there are the right triangle ABC and the inscribed circle. Radius of the circle is 2 and the three sides of the triangle are A, B, and 13. Let's say the three intersection points of the circle and the triangle as L, M, and N. According to the character of an inscribed circle and triangle, the lengths AL and AM are the same, and the lengths NC and CM are also the same. And their lengths are A minus 2 and B minus 2 respectively, right? So the length AC is equal to sum of AM and MC, which are A minus 2 plus B minus 2. So we can get A plus B is equal to 17. Plus, by the Pythagorean theorem, we can get A squared plus B squared is equal to 169. By the formulas of multiplication, we can find that 169 is equal to 289 minus 2AB. So AB is equal to 60. This is the solution to this problem. Is everything clear? Then let's move to the next problem. Here is the second problem. It's about the remainder theorem. Of course, you can figure out the remainder by dividing directly, but I would like to show you the different way of solving this. According to the remainder theorem, we can express the given condition as an equation like this. Here, Q of x is the quotient and the remainder is ax plus b. Because the divisor x minus 1 squared is the second order polynomial, the remainder r of x should be first order. So I express the remainder as ax plus b. If we put x equals to 1 into the equation, we can get a plus b is equal to 1. So b is equal to minus a plus 1. Then our equation can be written like this. We can remove the b. Here, this blue line can be factorized by a, and we can move plus 1 from right-hand side to the left-hand side. Then, the equation looks like this, and x minus 1 is a common factor of the right-hand side. So our equation is x to the 5 plus x to the 3 minus 2 equals to x minus 1 times x minus 1 cube of x plus a. Now just think about this equation for a moment. If we put x equals to 1 into the left-hand side, then it becomes 0. It means that x minus 1 can be a factor of x to the 5 plus x to the 3 minus 2, right? Let's factorize x to the 5 plus x to the 2 by using synthetic division. If we do it, it shows us this result. I hope you know how to do it, and please try to do it for yourself. So the left-hand side can be factorized like this, and our equation is written like this. Here, x minus 1 can be cancelled, and putting x equals to 1 into the equation will give us 1 plus 1 plus 2 plus 2 plus 2 equals to a. So a is just 8. And b is minus a plus 1, so it is minus 7. Therefore, the remainder r of x is equal to 8x minus 7. This is the solution to this problem. Is it clear? If it's clear, then let's move to the next part. Here is the third problem. M and N are second-order polynomials, and their least common multiple is x times x plus 1 times x minus 2. And M minus N is the same as their greatest common divisor. Because they are second-order polynomials, only those three cases are all the cases that they can be. If you choose any two things among three of them, their least common multiple is x times x plus 1 times x minus 2, as it's given in the problem. Let's choose those two polynomials and do subtraction. Then the result is x minus 2. And x minus 2 is their greatest common divisor, right? So m is x plus 1 times x minus 2, and n is x times x minus 2. This is the solution to the problem. Is it okay? Then let's move to the last problem. Here is the last problem. X and y are natural numbers, and it satisfies the following equation. Then, what are the value of x and y? If we use one of the formulas of multiplication, we can solve it logically. We already know this rule, right? If we divide both sides by a minus b, then it can be written like this. By using this rule, let's solve it together. The first term, 5 squared plus 5 plus 1 is equal to 5 to the 3 minus 1 over 5 minus 1. The second term, 5 to the 6 plus 5 to the 3 plus 1 is 5 to the 9 minus 1 over 5 to the 3 minus 1. In this case, a is 5 to the 3. Likewise, the third term is equal to 5 to the 27 minus 1 over 5 to the 9 minus 1. Okay? Based on these values, let's rewrite the given equation. Then it becomes like this, right? And all those terms are cancelled like this. So it can be summarized like this. 5 to the x plus 5 to the y plus 1 is equal to 5 to the 81 minus 1 over 5 to the 27 minus 1. 5 to the 81 is equal to 5 to the 27 to the power of 3. So it is 5 to the 54 plus 5 to the 27 plus 1. So x and y are 54 and 27 respectively. This is the solution to the problem. That's it for this video. I hope you enjoy it. If it was helpful, please click the subscribe and the like button. I wish you always be healthy and I will see you in the next video. Bye bye.